Okay, so the first, if you guys can go to and open the 03 rating case study, data cleansing and vectorize, please. And what I'm gonna be doing is that the first thing is that it's a kind of exercise, simple exercise here, that it says, wow, read the Excel file. So, so to read the Excel file, what do I need to do? Well, I'm gonna read into Pandas. So the first thing I need to do is I need to import Pandas, and I'm gonna do it with an alias. And then exactly, thank you very much, Jonah, because I can simply copy what Jonah has posted, and that worked. I can even do a simple print of the DF in here, just to see what's going on. You can see that the DF should look like that. If it doesn't look like that, it's because you haven't replaced with the new one. If you run it with me, or if you're running it watching the recorded version, because I sent by email a new version of the file. So please make sure you get that. If he only has a line, is a wrong one. I put a wrong one by mistake. So to select the name of our columns, that's very simple in Python. In Pandas, you just have to say .columns. There is a function for that, or that simply give you the list of columns. And to get all the values of a ticker, if you don't remember how to do that, you basically need to call it by name. You have two options. So it's saying ticker. You have the option of putting ticker here. That's the first option. Or you have the option of calling with the square bracket, and inside the square bracket you put the name ticker, and you get the same result. The good thing about this option here, and I'm gonna copy here and paste it underneath, is because it's asking me to do a peg ratio, and the problem with peg ratio is that it has spaces. So I rather use this option instead of the first one to do what they're asking here, that is select rows with peg ratios equal to none. No, I'll do that. Can you see better now, Rima? Yeah, thank you. Okay, so to selecting all the peg ratios equals to none, first, well, there is an option that is new, that will give me a list, an array saying false when it's not new or it's not none, and true when it's none. It's not exactly what I want, because I want to select all the rows where this is equals to none. So this is my, if you like, is my true and false vector or array. So what I need to do is put this as a selector or a filter in my data frame. So that's for you to remember what that means. To put a filter, you basically have to put something inside the square brackets. That's the way to do that. So what we're gonna do is, because this is an array of trues and falses, I can put it inside the bracket, and guess what? It's gonna tell me all values where the peg ratio is equal to none. So this way I can simply select all the rows that it's asking me to do. So pretty simple example of everything that we're gonna be doing. And the next thing is that you already seen this, but I'm gonna just remind you what we've done already, is that well, basically this is a dictionary, and we have a problem in the data frame, because my data frame, sometimes I get values, enterprise values, that has a billion, and sometimes it has other values with in here I cannot see it, but it has M for millions, K for thousands, and 3 for trillion, T for trillions, and a percentage sign for percentage. So what I need to do here is that, well, anything I'm going to be doing, a number with a B, Python is not going to be interpreting this as a number. Very likely is interpreting market cap as a text. Well, we can see this if we just simply say include a line here and put, I think it's df dot d type. So type is not type, it's not I think it's D types or something. I think if I get the columns, it already give me the. No, it doesn't. I got how to get. It's something like D type to get the type. But I'm sure this guy is describe. No, describe is a statistic. No, describe is a statistic. It's gonna tell the mean, max, and so on. But I don't know what it's gonna do with the price actually, because it's simply, you see, market cap, it's simply ignoring market cap. Why is it ignoring? Oh, D types, perfect, thank you, Rima. Describe is simply ignoring market cap, because market cap is not a number, it's a text. You can see that if I do this, if I say df D type, look, market cap is an object. It has no idea what that is. If it's a string, a float, it's considering an object, it's something. And basically, if you use describe, for example, it should be here because it's a number, but it's not. It's be ignored because it doesn't know what to do with that. So with market cap and other variables, we need basically to transform it into numbers before acting, before doing anything. So that's what we're gonna do. Let's run this piece of code here and then run this function here that won't do anything. We'll just put the function in the memory, text to number, and this function basically what it's doing is getting the magnitude and getting the number and putting it to putting the exponential float, the number 10 to the exponential. So if it's a k, if it comes as a k, you will say, is it a k? Because I have this dictionary, you will get the dk equals to 3. The dk will return a 3. The dm will return a 6. Therefore, we will do 10 to the 6th, the power of 6. And therefore will help me transforming the b into a 10 to the 9th, a t to a 10 to the 12th, and so on. This is my function. And because I have, if you remember, the doc string here, if I use this text to string help, it returns me the documentation. And in this documentation, you can see that what we're going to do is return 317 is going to return 3 billion, basically, as you can see here. I'm going to put this to the top. Very, very good. And this piece of code here is basically walking through the whole list of variables that I'm going to use for my modeling. So that's the list of fields. And then I'm creating a new list of fields here because I'm creating a list of fields where there is no date, because the list of fields with no date on it is the one that I'm going to be transforming. I'm going to be applying the text to number function. Okay, so if I run this piece of code, what I should get now is that market cap now has a value, and then enterprise value, same thing. So if I do the same stuff now, if I create a new row with the plus here, plus sign, and then now I say df.dtype as we run now, market cap now is a float, enterprise value now it's a float. So now I have a database, a data set that I can work on, because everything now is a number, and I can start doing things. So, and well, because of this transformation, I still have to do something else for some data cleansing. That is, I have to replace, remember the nuns that we do with the peg ratio? Well, let's do a transformation as well. So I'm going to do with all the fields, if I find a none, I'm going to replace it with 0, just for simplicity at this point. And then I can save my data set. And where did I save it? How did I save it? With 2Excel function. And I saved a file called Yahoo Ticker Sample Clean.xls. So if I go to my folder where I'm working, I should see a file just created just now, and if I open, it should have what I've done, the transformed version and so on. No, that's not this crap. It's probably because I'm not working on this plate that my one is not. Overall, it's, you cannot force it to be. You could do the. I know there are some options in Pandas to do formatting and to do well, formatting would work, but to transform things from type, to say S type something, but that's not a type. Letter B, as we had in the beginning, letter B is not a number. It's really a text. So that's the problem. you have to replace it, and because that's your interpretation when we read it, that's your interpretation that B means billions and that K means kilogram, kilo, 1,000, but that's your interpretation. That's not numbers, and that's why I put the videos here for Socratica talking about numbers in Python and so on, okay, because that's not the interpretation of the normal language. So that's why we had to do that this way, by replacing things, okay? If you think there may be other type kind of transformation for pandas, okay? Good. So now get prepared for a heavy stuff. So take a breath. I'm gonna drink some water and let's see how we go with time with this discussion. I asked you guys to watch some videos and I hope you do. If you haven't, I hope you do after this. The video regarding list comprehensions, lambda function, and map, filter, and reduce. It's just a quick discussion of why what we're gonna see now is why I've used the function vectorize in here. You can see here that I'm using a function vectorize. Why am I using that? Well, the reason for vectorizing you're gonna see now is, and for understanding deeply why I'm using this, I hope, and comparing with the list comprehension, you need to understand what list comprehension. I don't have time to cover it, so but you have the videos for list comprehension, lambda function, and map. Why I'm applying is because you need to you're gonna see Michelle. Let's see what we're doing. Let's suppose we have this function here. Whatever this function is doing, it doesn't really matter. It's just calculating something, but it's a complex enough function that is calculating this calculation here. It doesn't matter what it does. But let's suppose I want to calculate this function for 100,000 element. Okay, so this is enough. 100,000 is a good number, and I create 100,000 data point for list X and Y, and then I'm gonna just create a graph here for you to see the stuff. But the important thing is that I'm gonna compare 4 different ways of calculating the stuff. I can calculate that by simply applying the function on a for every data point in the list. Okay, I can do that just by simply calculating. I don't need a function to complicate my life. I'm gonna take the time of it. Okay, we're gonna time it to see how long it takes. Then I'm gonna use a powerful thing from Python that is called list comprehension. I'm gonna create the function. Well, the function is defined on the top here. It's already defined here. So I'm gonna call the function down here and zip it the 2 lists together so that I can call the function for my function X and Y. This is going to speed up the process a lot. List comprehension is great stuff. Okay, it's a bit tricky to use it. That's the video there explaining how to do it, but it's very cool and very powerful, and I'll explain why in a bit. Python also has the map function that can map the function and apply it to a list. The way of calling the map function is quite easy. You call map, you give your function, and then you give all the attributes of the function. Quite easy. We're gonna time it again. I'll tell you what the zip function does in a bit. Okay, and I think I have the. Oh yeah, I'll do it anyway. And then we have the vectorize option. The vectorize option, it gets the vectorize and then the function, the attributes X and Y. So basically 4 different ways. No more talking, enough talking. Let's just run it and see how long it takes. So the plain vanilla calculation took about this millisecond. The list comprehension took 77 milliseconds. The map function took this much milliseconds to calculate, and the NumPy vectorize took 50 milliseconds to run. That's the same. Look how long it took for the simple for to run. It takes much longer, and the list comprehension is much faster. However, the fastest of all is the NumPy vectorize. And why is that the NumPy vectorize is better? Is because the NumPy vectorize runs in C, not in Python. You know, Python is built on top of C. Is that the Michelle? That's not all. That's I can tell you and I can tell when that may not be the case. Okay, where well, NumPy, let me just finish with the NumPy, and then I'll get to the point where you ask. The NumPy function is built on C. Well, Python is built on C, and then Python obviously is built on C for a reason. It's built for simplicity, for beauty, for making it easy, and so on. However, C is going to be faster because Python is a layer on top of C. So obviously, it may take more time. However, Python has some options that you actually read it and run it in C instead. And the three options that you do is list comprehensions. List comprehensions is not running in Python. Map is not running in Python, and NumPy vectorize is not running in Python. Therefore, the three ones are much faster than running a simple loop in Python. Okay, so the tree actually runs on C. However, the difference in the vectorize is that it runs on top of running in C, is built by the best library in the terms of performance in Python. What's library is that? NumPy. When you talk about performance in Python, NumPy is the library to go after. And where is Pandas built on? Is built on top of NumPy. Therefore, that's why Pandas enjoy the power of NumPy. However, map function is something already built in Pandas. You can use Pandas. In Pandas, you have the option apply. The option apply, behind the scene, what it's actually doing is a map. However, if you do need performance, the apply is not as good. I don't know why they chose the apply function instead of implementing the vectorize function. That is the pure NumPy way of applying things that is built on C, and on top of that is pretty faster, but is much faster. And then coming back to Michel's question, is always the case. Michel, basically NumPy vectorize is built for NumPy array. So if you are in NumPy arrays, Pandas is NumPy arrays. So every column of a Panda is a NumPy array. If you're playing in that field, vectorize is gonna be always faster. Okay. However, in the case that we are playing now, we didn't create a NumPy array. We've created only a list, and even that NumPy vectorize was faster. That may not be the case. Okay, if you're working with lists, that may be not the case. So that's the case where I would still use vectorize because it is very robust in lists as well, and it makes my life simpler than complicating my life with list comprehension. However, I can promise you that a well done list comprehension can be faster than a NumPy vectorize when you're talking about lists. When you're talking about pandas that are NumPy array, vectorize are going to be faster. So I don't know if I answered your question on that. And that's what comes here in the next example. So let's just do a simple comparison of pandas apply and NumPy vectorize. So if I run this piece of code, basically I'm creating again 100,000 row DF, a data frame. It's gonna take a while to create it. Well, you've created Bob many times. Bob 130, Ken 22, Steve 313, and then it repeats. Basically, if I do the apply function right now, you can see now I have 400,000 rows and 2 columns. So I'm gonna do something, just do a simple function on that and time it with the lambda function that calculates if the row pending is above 500, put letter B, otherwise put letter A. Oh, sorry. If it's above 100, letter A, otherwise letter B. Very simple function, but that's the way you do with lambda function. That has to be written in this syntax. It's a bit untrivial for people that are beginning in Python, but it will take a time to run it. Don't worry, vectorize will also take a little bit of time, but as you can see, this is the normal way of writing the function. And let's see, hope it doesn't take forever. to run it. Well, it took 6 seconds to run the first one. This obviously is the normal way of writing a function. You don't need to learn much more to do that. And basically, it only took 133 milliseconds. Are you convinced that it's faster? And I promise I don't understand why Pandas chose to do apply instead of behind the scene. You do apply, but it actually applies as vectorize. It calls the NumPy function instead. I really don't know, but I know that for you guys, I'm giving this example that it does justify to go straight into NumPy when you apply a function, a complicated function to a data set, okay? And you have to apply to all rows. And so here you have some documentations about it, okay? And as a exercise, I would ask you, as a bonus exercise for a participation point, is a bonus. You can win it if you want to participate. Please write a function and send it to me by, I'm putting 10 a.m. on Monday because some people, the Sunday will be my Monday, so it's the 23rd of April, 10 a.m. So this is an exercise. Just write your own function and send it by email to me, to mfalonso faculty.ie.edu by email, and call it as the NumPy vectorized exercise. It's a bonus exercise that you can send it to me. It's basically going to be doing the same sort of things that I've done here, but you have to read what I actually wanted you to do, a yes or with the price and so on. So it's to prove that you know how to do it. It's a bonus. It only counts for participation. Okay. You can do it in here, and what I want